This is question 4, parts 1 and 4 from exercise 4.1 in Project Maths 3A. We have to use Pythagoras Theorem to find x, the length of the missing side, insert form where necessary, and then express the sine of theta, the cos of theta, and the tan of theta as simple fractions or as third fractions in each of the following. So we'll look at part 1 first. We've been given a right angle triangle with sides marked 13, 12, and x, and an unknown angle marked theta. And the first thing we have to do is use Pythagoras' theorem to find the length of x, the missing side. Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. You can find a video explaining this further back in my channel, and I'll put a link in the description below. But we'll get started with that. So for this, it's going to be 13 squared is equal to 12 squared plus x squared. 13 squared is 169, 12 squared is 144, and x squared is just x squared. Now we need to get this solved, so we're going to bring our 144 over. So we get 169 minus 144 is equal to x squared, which means 25 is equal to x squared, which would mean that x is equal to the root of 25, so x equals 5. Okay, so now that we know the value of x, now we've got to mark out the sine, cos, and tan of theta from this triangle. So we have x equal to 5 in here. So we'll start off with the sine of theta. In a right angle triangle, the sine of an angle is the measure of the opposite side to the angle over the hypotenuse in the triangle. In this case, it's going to be 12 over 13. And then for the cos of theta, in a right angle triangle, the cos of an angle is going to be the measure of the side that is adjacent to it, which in this case is 5, over the measure of the hypotenuse, which is 13. So it's going to be 5 over 13. And then we're going to get tan theta. And then in a right angle triangle, the tan of an angle will be the measure of the side opposite it over the measure of the side adjacent to it. So in this case, it's going to be 12 over 5, like that. So that's how we will do part 1. Now part 4 is where we're going to see the bit from the question where it says in third form where necessary, or as third fractions in each of the following. So we'll use Pythagoras' theorem first to get our value for x. So it's going to be the root of 13 squared is equal to x squared plus 1 squared, which means 13 is equal to x squared plus 1. So 13 minus 1 is equal to x squared, which means x squared is equal to 12. So x is equal to the square root of 12, like that. And we don't need to get the square root of 12, we can leave it in third form, which is what this is just here. So from here, we're going to get the sine of theta, the cos of theta, and the tan of theta. And theta is the angle marked in the top right, just up here. And we have x is equal to root 12. Okay, for sine, sine, as before, is going to be the measure of the side opposite the angle over the hypotenuse. This time the opposite side to the angle is the side marked 1. It's opposite, it's on the other side of the triangle from it. So it's going to be 1 over root 13. Cos of theta is going to be the side that is adjacent to our angle, which in this case is the root of 12 over the hypotenuse. So we're going to have root 12 over root 13. And then for the tan, it's going to be the length of the opposite side over the adjacent side. In this case, it's going to be 1 over the root of 12, like that. And that is that.